All right, so this is going to be a walkthrough of this binary representation of data worksheet. So the very first section is going to ask you to take numbers written in binary, convert them to decimal, and numbers written in decimal and convert them to binary. Now, the most important part to start with is to recognize that numbers in binary are broken down into these columns, so the 1's column, 2's column, 4's column, in the exact same way that base 10 numbers are broken up. So I'm going to draw that on the side and write another number over here. How about 3, 4, 7, 9, 2, 6? And in base 10, this would be the 1's column, and then the 10's column, then the 100's column, then the 1000's column, then the 10,000's column, and the 100,000's column. I think I'll stop there. That's probably enough to make the point. So we do math in our heads every time we see a big number like this. If I were to say it out loud, I'd say 347,926. Well, that's because it's 3 100,000s, 4 10,000s, 7 thousands, 9 hundreds, 2 tens, and 6 ones. Add all that together, and you get 347,926. The same thing's happening over here. So let's figure out what number is represented here. Well, it's 1, 1, so I got a 1, and I have 1, 2, plus a 2. I don't have any 4s. I have 1, 8. I have 1, 16. I have no 32s, no 64s, and I have 1, 128. So this number is just adding these up. Now, it seems a little different in binary because when we add numbers up in decimal, they add real nicely. If we go back to this number, we had 300,000 plus 40,000 plus 7,000 plus 900 plus 20 plus 6. Now, there's no carrying of any numbers. It just works out nicely. That's why we use base 10. It's really simple for us. But for computer, binary is simpler, so we have to add these numbers a little bit differently. 128 plus 16 is 130. 144 plus 8 is going to be 152 plus 2. 154 plus 1 is 155. So that's the number 155. Now, that example is a little tough, so let's use a simpler one. This first example we have here has a 1 in the 1's column and a 1 in the 128's column. And I'm using this as a cheat sheet over here. That 8th bit is in the 2 to the 7th and 128 column. So I have 128 plus 1. That's 129. In this next one, I have a 1. I also have a 2. No 4s, but I have an 8. I have a 16, and I have a 128. All right, well, that's this number that we just figured out. 128 plus 16 plus 8 plus 2 plus 1 is 155. How about this one? We got no 1s, but we have a 2. We have a 4. No 8s, no 16s. We have a 32. We have a 64. So 64 plus 32 is 96. Plus 4 is 100. Plus 2 is 102. For this one, we have one of each of the 4 numbers. So we have a 1, a 2, a 4, and an 8. That's 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. And in this example, we have all the higher numbers and none of the lower ones. So we got a 128 plus a 64 plus a 32 plus a 16. So we got 128 plus 32. I'm going to do those two because the 2 adds in easily. Actually, let's do it this way. 128 plus 32 is 160 evenly. Plus 64 is 224. Plus 16, oops, sorry, is a 4. So we got 240 here. So there's my decimal numbers for those binary representations. Now we're going to do the opposite. We're going to take a decimal number and convert it into binary. This is actually a lot easier. So let's start with 17. I need to make 17 out of these numbers. So I can only add these numbers together to get 17. Well, the biggest number that fits into 17 is 16. So I know I need to have a 16. And then I need to add a 1 to it. So that means I need to write the binary that shows me 1, 16, and 1, 1, and nothing else. So we tend to write binary in 8 bits at a time, also called a byte. So let's do that. No 128, no 64, no 32, but I do have a 16. And then no 8, no 4, no 2, but I do have a 1. That's it. Let's try it for 4. Well, this one's really easy. It's just a 1 where the 4 is. So that means no 1, no 2, 1, 4, and then zeros for everything else. 0 is even simpler. There's just nothing. So we write 8 zeros. 255. Now, you might notice that 255 is really close to the number 256. And 256 is double 128. So if we were to add one more bit, if we had another column, we'd have a 2 to the 8 or 256 column. But since we don't, we need to make that number up with everything that's left. Now, the number in each column, or the value of each column, is always going to be 1 less than the column to its left if you add everything up. So 1 is 1 less than 2. If you add those up, 3 is 1 less than 4. If you add those up, you get 7, which is 1 less than 8. If you add those numbers up, you get 15, which is 1 less than 16, and so on and so forth. So knowing that, we can just skip ahead and say 255 is all 8 of those bits turn on. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 gives you 255. Now lastly, 197. Well, this one we're going to actually work out. 128 goes into it, so I have 128. Now what do I have left over? Well, let's subtract. We get a 9 here and a 6. Well, 64 goes into 69, so I take out the 64, and I'm left with 5. Well, 32 is too big, 16 is too big, 8 is too big, 4 is a good size, minus 4 gives me 1, so no 2 and a 1. So there's our binary for the top. Now, knowing that conversion should make the rest of this easier. But let's take a look at the second part, the binary addition. We're used to doing addition like this, 3 plus 4. And we usually write it as columns. 3 plus 4 equals 7. Well, let's do this in binary. A 3 in binary is 0, 0, 0, 0, 0, 0, 1, 1. And a 4 in binary is 0, 0, 0, 0, 0, 1, 0, 0. Well, we end up adding in binary the exact same way we do a decimal. You line up the columns and you add. 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0, 0, 0, 0, 0, 0. This is the number 1, 4, 1, 2, and 1, 1. Add those up and you get 7, what we're supposed to get. Yay! Well, let's try a couple other ones. How about 8? That is, or 8 plus 8. 8 plus 8 equals 0, 0, 0, 0, 1, 0, 0, 0, plus 0, 0, 0, 0, 1, 0, 0, 0. Add those up. 0 and 0 is 0. 0, 0, 0. 0, 0 is 0. 1 plus 1 is 2. But I can't put 2. 2 can't fit in binary. In the same sense that 16 can't fit here. I cannot put a number bigger than 10 in this column. So what I do is I put what's left over when I go to the next column. So I put a 10 up here. I carry that 1. And I put my 10 down. So, well, what's left over is the 6. In the same sense, I do that here. A 1 and a 1 gives me a 1 on this side, and I got nothing left. So now 1 plus 0 is 1, 0, 0, 0. So I end up with 0, 0, 0, 1, 0, 0, 0, 0, and that 1 is in the 16th place, the 16 column, which is exactly what I expect. How about 127 plus 1? Well, 127 is 0, 1, 1, 1, 1, 1, 1, 1. And 1 is 0, 0, 0, 0, 0, 0, 0, 1. 1 plus 1 gives me a 0, carry the 1. 1 plus 1 is a 0, carry the 1. 0, carry the 1. You can see that this is going to keep happening. Keep carrying that 1 until eventually I carry it here. 1, 0, 0 is a 1. 128, exactly what I'd expect. So binary addition is actually really simple, a lot simpler than decimal addition. And this is why computers use binary. You can actually build a circuit to do all those addition problems very, very, very easily. And then a computer thinks, even though really it's just passing electricity through a circuit. So last piece of this worksheet is to use the Ascii table to write your name. Now the Ascii table is just an easy way to translate from numbers to letters, because the computer can only store things in binary, and we can translate binary into decimal numbers. So then if we have some library or some table that tells us that decimal numbers can be translated into other symbols, then we can use another symbol set. And the Ascii table does just that. So for example, in the Ascii table, 65 corresponds to a capital A. 66 corresponds to a capital B. 67 corresponds to a capital C, etc., etc., etc. So if you look up the Ascii table, ASCII, you can find out all the decimal values of letters. So if you were to write your name, in my case, Kevin, you can then take your letters and convert them into decimal numbers. Now I don't know all these off the top of my head, but if I were to keep going with this, A, B, C, D, E, I would see that an E is 69, so I'd make that 69. And then I want to convert it one more time into binary. So 69 in binary, I thought we did up here somewhere, so I could use it as a quick cheat sheet. Well, if not, I can make it real quick. I need 164, so I'd have 0 for 128, 1 for 64, and then I need a 5. So that'll be 1, 4, 0, 2, and 1, 1. This right here is the letter E stored on your computer. So whenever I type my name, Kevin, on a computer, there's 8 bits that are used to keep track of that E. Oh, if it was capital. So let me fix that because I don't want to make anybody confused. So that is a quick walkthrough of how to do this worksheet. Hopefully you found it helpful. Bye now.